And then expiratory limb then comes down from this straight line and then reaches here and then goes up again and reaches your straight line. And this is got. Today we are going to find a very simple technique that how to compare and contrast the normal pattern versus restrictive and obstructive pattern on spirometry. But for today's lecture purposes, we can say we are going to talk about lung volumes, capacities, flow volume loops, obstructive and restrictive pattern. So first of all, we will quickly go through lung volumes and capacities. If people expire out maximally, whatever amount of air is left in the lung is called residual volume. While functional residual capacity is a capacity which is left in the lung after normal expiration. Means if people expire normally, whatever is left behind in the lungs is called functional residual capacity. Then we have got total lung capacity, which we can see if we combine lung volumes plus capacities. Now let's define what is FEV1 or forced expiratory volume in the first second. If you people expire in the first second, if spirometry is going to record your expiration in the very first second, the amount of air expired in the first second is called FEV1, right? And if we just get an example of FEV1, we can suppose it as 4 liter. For example, if a patient's FEV1 is 4 liter, it means that this patient's forced expiratory volume in the very first second was 4 liter. Like if I'm expiring over here, right? Now, if this expiration is recorded in the very first second, right, it will be FEV1, right? It means in the second, third, and fourth, and fifth second, and so on, we don't record this FEV1, right? Forced vital capacity is contrast to FEV1. This is the total expiration, irrespective of the time. Here, you people are not looking to watch whether 1 second is elapsed, 2 or 3 or 4 or a minute is elapsed. This is the total expiration that you people do, and we can assume it as 5 liter. Now we want to take the ratio of FEV1 and FVC, right? Okay, so here we will take 4 divided by 5, which is equal to 80%. So the normal FEV1 to FVC ratio should be 80%, right? Now, if you people can see over here, if the patient's FEV1 ratio is less than 80%, it means this patient is suffering from obstructive pattern. This is the normal basics that you people have learned. If we get another example where the patient's FEV1 to FVC ratio is more than 80% or 80%, it will be restrictive lung disease. It will be restrictive pattern, right? So now, if we concentrate over here, if you people take a look at flow volume loops given in spirometry, this normal pattern has got 2 limbs. One is our expiratory limb, which starts from this flat line. It goes above and reaches over here, and then comes down like this, and then ends on flat line again. This has got the shape of inverted V, right? So this is inverted V. Just above the flat line is your expiratory limb, right? This is the extent of expiratory limb in normal pattern. Now, if you people can see over here, we have got a straight V, right? This straight V actually starts below the straight line, right? This is your inspiratory limb. Why knowing inspiratory and expiratory limb is very important for you people? Because we want to know that which limb has got problem. Is it expiratory limb, right, which is seen in obstructive lung disease, or is it inspiratory limb which is seen in restrictive lung disease, right? This is the normal pattern. This was the first example, right? And it's a normal pattern that you people have got over here, right? Now let's take a look at this second example, right? In questions in USMLE step 1, step 2, or whatever exam you people are opting for, you people will be giving a normal pattern along with abnormal pattern mostly, right? But in clinical practice on spirometry, this normal pattern, which we have highlighted over here, drawn through blue marker, this will not be given in clinical practice, right? This in exam, this normal pattern is given so that you people can compare and contrast this with patient's pattern, right? So this is the normal pattern. The expiratory limb is starting from here and then reaching here, then going down, and then it's coming back towards this flat line. And then expiratory limb then comes down from this straight line and then reaches here and then goes up again and reaches your straight line. And this is got straight V-shaped pattern, right? Now we have to compare this this blue one with the black one, right? The blue one is normal for us, right? Blue one is normal. This is normal. This patient hasn't got any problem, right? This is the normal one. Now let's compare and contrast this blue versus the black one. You people can see over here that this is the expiratory limb, this downgoing pattern, this downgoing line should be very oblique. This should be oblique. But if you people can see over here, this has scooped down here like this, right? This is called scooping. This has got convex shape, right? This has got convex shape. This is not oblique, right? The moment you people see this scooping, you people can easily say that this patient has got an obstructive disease, right? Now, how easily we labeled this scooping as obstructive pattern? This is the question. See over here. Earlier we emphasized on this expiratory limb and inspiratory limb. Just above the flat line, it was expiratory. Just below the flat line, it was inspiratory limb, right? So over here we focused over here. We found out that in the expiratory limb, there was an abnormality over here. It had scooped out, right? This scooping actually told us that this is the expiratory limb that has got problem. Now, if I ask you people that you people should compare and contrast obstructive versus restrictive lung disease, you people will easily say that this is the obstructive lung disease that has got problem with expiration, right? In obstructive lung disease, you people have problem with air getting out of the lungs, not air getting into the lungs. So as you people have got problem with air getting out of the lungs, you people will have problem in expiratory limb. And what is the shape of this and what's the shape of expiratory limb in obstructive lung disease? It is scooping. Now we will take a look at third example, right? Over here you people can see that this normal one is highlighted through blue marker, right? This dot shaped, right? This is the normal pattern, right? But if you people can see over here, this is the patient, right? This is patient. But we don't know the disease as of yet, right? Whenever you people are looking at flow volume loops, first of all we should realize that is it the expiratory limb or inspiratory limb that has got problem as compared to the normal pattern that we have. Now see over here, in this expiratory limb, though the peak of this expiratory limb is not as high as seen in this normal pattern right over here, but we can easily say that there is no scooping, right? The upward portion and downward portion of expiratory limb is absolutely oblique, right? It hasn't got any convex or scooped out portion, right? There is no scoping, right? It's absolutely oblique. So we can safely rule out obstructive lung disease. So obstructive lung disease is ruled out. Now take a look at inspiratory limb, right? Let me remind you people that whenever we are going down from the straight line, the more proximal you finish over here in this down going line, just below the straight line, the less is the volume, right? For example, if you people finish over here, it will be 2. If you people finish here, over here, it will be 4 liters, right? Over here, it will be 8 liters. So now let's look at inspiratory limbs peaks, right? We will compare patient's inspiratory limb peak versus normal inspiratory limb peak over here, right? So you people can see here that patient's inspiratory limb is finishing over here, right? It's on the 4, right? It has got 4 liters, right? We are now comparing it with the normal one, right? The normal inspiratory limb peak over here. It is almost 7 liters. So you people can see over here that in this patient we have got problem with inspiratory limb. So it's very easy to understand now that we have got which pattern over here? Restrictive lung disease. So it's a restrictive pattern. How did we know? We just compared and contrasted the inspiratory limb peak in patient and normal pattern, right? So we concluded that patient's inspiratory limb peak is only 4 liters, while normal inspiratory limb peak in this specific example is 7 liters, right? It may not be very correct physiologically. We are just taking an example, right? In our example, this patient has got restrictive lung disease, right? So for obstructive lung disease, you people have to look at scoping. And for restrictive lung disease, you people have to look at inspiratory limb and its peak, right? You people have to compare and contrast. Patient's inspiratory limb peak downward and normal inspiratory limbs peak downward.